Hello my students, in this video we are going to focus on integral of trigonometric functions. We have studied before the derivatives of trigonometric functions. The differentiation we have studied before the derivative of trigonometric functions. And if we need to find the derivative of sine x, it's going to be cosine x. And the derivative of cosine x is going to be negative sine x. And the derivative of tan x will give us 6 squared x. And the derivative of cotan x will be negative cosec squared x. And the derivative of sec x is equivalent to sec x tan x. And the first derivative of cosec x will give us negative cosec x cotan x. So we have studied before the 6 trigonometric functions or the 6 derivatives basic trigonometric functions. By using the definition of antiderivative of the function, we can deduce the rules of integral of some trigonometric functions. The rules of integral of some, we can say for famous trigonometric functions, as the following. Actually, as we have studied before, the derivative of the left side will be the right side. The derivative of the left side of sine is going to be cosine, cosine negative sine, tan 6 squared, cotan negative 6 squared, and so on. So the derivatives of the left side is going to be the right side. And as we have studied before, the integration, the reverse or the inverse operation of the differentiation. So if we integrate the right side, we will find the left side. If we integrate the right side, we will find the left side. If we differentiate the left side, we will find the right side. And if we integrate the functions of the right side, we will find the left side. So we can deduce the rules of integral of some trigonometric functions. So the integral of cosine x with respect to x, the integral of cosine x with respect to x is going to be sine x, because the first derivative of sine x is going to be cosine x. But don't forget plus the constant, plus c. And if we need to find the derivative of the antiderivative of sine x, if we need to find the anti-differentiation of sine x, the derivative of cosine x is going to be negative sine x. So the anti-differentiation or the integration of sine x, it will give us negative cosine x plus c. And if we need to find the integration of cosec or sec squared x with respect to x, if we check the table, the derivative of tan x will give us sec squared x. So if we integrate sec squared x, it will give us tan x plus c. If we integrate the function of cosec squared x with respect to x, the derivative of cotan x is equivalent to negative cosec squared x. So if we integrate cosec squared x, it's gonna be negative cotan x plus c. If we need to integrate the function of sec x tan x, if we need to find the integral of sec x tan x with respect to x, if we check the table, the differentiation of sec x will give us sec x tan x. So the integral of sec x tan x is gonna be sec x plus c. Finally, if we need to integrate the function of cosec x cotan x with respect to x, we know that the derivative of cosec x will give us negative cosec x cotan x. So the integration of cosec x cotan x is going to be negative cosec x plus c. So now we have the rules for trigonometric functions, basic trigonometric functions. Or we can say the rules of integral of some trigonometric functions. The integration of cosine x, it will give us sine x plus c. And the integral of sine x, it will be negative cosine x. You have to memorize these rules. And the integral of sec squared x, it will give us tan x. And the integral of cosec squared x, it's going to be negative cotan x, and the integral of sec x tan x, it will give us sec x plus c, and the integration of cosec x cotan x, it will be negative cosec x. But before solving some examples on the integral of trigonometric functions, we have to remember, or we have to memorize these trigonometric important relations. The 6 trigonometric identities and the 3 Pythagorean trig relations, trig functions. First, we have studied before that cosine x is equal to 1 over sec x, and sec x, the reciprocal of cosine x. So sec x is equal to 1 over cosine x. And also we have studied before that sine x is equal to 1 over cosec x. So cosec x is equal to 1 over sine x. And also we have studied before that tan x is equal to 1 over cotan x, and also is equivalent to sine x over cosine x. So cotan x, which is reciprocal of tan x, is equal to 1 over tan x, and also is equivalent to cosine x over sine x. And we have the three Pythagorean trigonometric relations. We have three important Pythagorean trigonometric relations. The first one, cosine squared x plus sine squared x equal to 1. And 1 plus tan squared x is equal to sec squared x. And 1 plus cotan squared x is equal to cosec squared x. So we have to memorize these relations because we are gonna use these relations in solving integral problems. Let's see problem 1. Evaluate the following integrals. Three Pythagorean, cosine squared x plus sine squared x is equal to 1. 1 plus tan squared x is equal to sec squared x. 1 plus cotan squared x is equal to cosec squared x. Evaluate the following integrals. The first one, we need to find the integration of cosine x over sine squared x with respect to x. So we need to find the integration of cosine x over sine squared x. But as we have studied before, we don't have a product rule, quotient rule in the integration like the derivatives. So we have to use some techniques like converting 1 over sine or 1 over cosine by trigonometric relations that we have studied before. So we have to rewrite the expression. And we know that 1 over sine x, we have the integration of cosine x over sine squared x. We can convert it to sine x times sine x. So this expression is equivalent to cosine x over sine x times 1 over sine x. So we are going to simplify the expression as possible as you can. Then we are going to find the integral of the simplest form. So we have cosine x over sine x. Actually, we can convert it to cotan x. And we have 1 over sine x, which is reciprocal of sine, which is cosec x. So we have the integral of cotan x times cosec x. And we know that the integration of cosec x cotan x is going to be negative cosec x. The integration of cotan x cosec x or cosec x cotan x with respect to x will give us negative cosec x plus c. And this is the final answer. So we are going to simplify the complicated expressions according to trigonometric relations to easily find the integration of these expressions. That's the point. So let's see example 2, problem 2. If we need to evaluate the integral of sine squared x plus cosine squared x over cosine squared x dx. Again we have a fraction. Again we have a quotient of two functions. And we don't have a quotient rule in the integration. And also we have sine squared and cosine squared. And till now we don't have an integration, a directly rule to the integration of cosine squared or sine squared. We know that the integration of cosine x, sine x, and the integration of sine x, negative cosine x. But we don't have a rule till now to solve sine squared x, to solve the integration of sine squared x. So we have to use the famous trigonometric relations. We know that cosine squared x plus sine squared x, the first Pythagorean relation. So we can replace sine squared x plus cosine squared x by 1. Then we have the integral of 1 over cosine squared x. And we know that the reciprocal of cosine x, which is sec x, 1 over cosine x, is equivalent to sec x. So 1 over cosine squared x is equivalent to sec squared x. So we have the integral of sec squared x dx. Then easily we can find the integral of sec squared x, because we have in the table the integral of sec squared x dx is going to be tan x. So we have tan x, and don't forget plus the constant. And this is the final answer. The third problem, if we need to integrate cosine x plus sine x plus 6 squared x dx. We can easily apply the sum rule in the integration. So we need to find the integral of cosine x dx plus integration of sine x dx plus the integral of 6 squared x dx. The integral of cosine x is going to be sine x plus the integral of sine x negative cosine x plus the integral of 6 squared x tan x plus c. And also we can find the simplest form, sine x minus cosine x plus tan x plus c. And this is the final answer. Problem 4, example 4. If we need to integrate 1 minus cosine squared x over sine x dx. Again, we have a quotient of two functions. And we have 1 minus cosine squared x. And we know that cosine squared x plus sine squared x is equal to 1. So 1 minus cosine squared x is equal to sine squared x. So easily we can replace 1 minus cosine squared x by sine squared x. So we have the integral of sine squared x over sine x dx. Then easily we can simplify one sine from the top by sine the bottom. So we have the integration of sine x dx. It will give us negative cosine x plus c. Problem 5. If we need to integrate sine x over cosine squared x dx. We have sine x over cosine squared x. So if we distribute cosine squared x to be cosine x times cosine x, so we have sine x over cosine x times 1 over cosine x dx. And we know that sine over cosine, it will give us tan x times the reciprocal of cosine, which is sec x dx. So easily we can find the integration of tan x sec x, which is sec x plus c. Problem 6. We need to integrate 1 plus cotan squared x with respect to x. 1 plus cotan squared x. We don't have the integral of cotan squared x, so we have to use the trigonometric relations to simplify the expression. 1 plus cotan squared x is equal to cosec squared x, and we have the integral of cosec squared x, which is negative cotan x. So easily we can find this integral by simplifying the expression. So we have the integral of cosec squared x dx, and the integral of cosec squared x will give us negative cotan x plus c. Problem 7. If we need to find the integration of cosine squared x plus sine squared x plus tan squared x with respect to x, how can we find the integral of this expression? So we are going to distribute the integral of cosine squared x plus integral of sine squared x plus integral of tan squared x. But here we have a problem, because we don't have the integral of cosine squared or sine squared even for tan squared. So we have to solve by another technique. We know that cosine squared x plus sine squared x is equal to 1. So the integral of 1 plus tan squared x dx, and we know that 1 plus tan squared x is equal to 6 squared x, and we have studied 6 squared, the integral of 6 squared x will give us tan x. So we have the integration of 6 squared x dx, it will give us tan x plus c, and this is the final answer. The last problem that we have today, example 8. If we need to find the integration of 1 plus cosec x times between two brackets times 1 minus cosec x dx. So here we have a product of two functions, and we don't have, as we have studied before, we don't have any product rule or quotient rule in the integration. So we are going to use some algebraic techniques. We have a product of two brackets, so we can simplify by using FOIL. So we are going to multiply the first times the first, then the outer, then we are going to multiply the inner, then the last term by the last term. So we have the integral of 1 times 1, which is 1, 1 times negative cosec x, negative cosec x, cosec x times 1 plus cosec x times negative cosec x, negative cosec squared x with respect to x. And then easily we can simplify cosec x cancelled with negative cosec x. So we have an integration of 1 minus cosec squared x dx. One minus cosec squared x. If we use the Pythagorean relation, 1 minus cosec squared x, it will be negative cotan squared x, but we don't have the integration of negative cotan squared x. so you are not gonna use this relation. And we have the integration of cosec squared x. The integration of cosec squared x will give us negative cotan x. So we have to distribute the integration of 1 dx minus integration of cosec squared x dx. So the first part will give us x minus cosec squared x, the integration of cosec squared. It will be negative cotan x, so we have plus cotan x plus c. And this is the final answer. I hope this video helped you. Don't hesitate to contact me if you need any help. Thank you. See you soon.